Okay, basically today, yesterday we discussed about how quantum traction theory can actually correct general relativity contradictions with quantum physics. Not only with quantum physics in larger scales, about basically galaxies, speed of galaxies, and also expansion of universe, dark matter, dark energy. Now today what we are going to discuss about this theory and basically Copenhagen interpretation specifically, and what is fabrica. We defined something called fabrica. We are going to actually have it here. Okay, we use alpha here from other side, right? Okay. No. Actually, let's use at sign. What do you think? We are inventing it. Okay, cool. Okay, we use fabrica like this. Then we can actually use it in our videos better. Anyway, basically this fabrica has certain properties. And today we are going to discuss about these properties. Fabrica is something that we said it's defining a space and time. Now we are going to discuss the properties and what is happening with fabrica. Basically, we define basically 5 dimensions on fabrica. Yesterday we discussed reality, x, y, z, t, and basically what we can call the 4th dimension in the space. Like let's say space has 4 dimensions after z. Okay, we can call it
Z1.
Good. So fabrica has 5 dimensions in our calculations. It has dimension 4, basically space dimensions, and it has reality dimensions that we are going to discuss, and it has time, and basically it has certain properties. The property of fabrica is gonna be the first property. We are gonna call it handshaking. What handshaking means? Barpa effect. Basically, in this system, we defined fabrica as very small entities, but that's not all what fabrica can be about. Fabrica can be as small as Planck and as big as universe. What that means? Basically, a finite number of fabricas, they can get connected together like a marshmallow, and we can call it Barpa effect, and they are gonna represent same time and same space. What that means? That means, let's say you have a balloon in hand, but this is a very, to be honest, not that kind of right expression. You have a balloon in hand, right? You press it. You press this balloon, and then it will become 2 balloons. The gas, everything between these 2 balloons are kind of shaped, but they are like 2 balloons. In reality, like they are like 2 different balloons. But if you basically do something to this balloon, it will affect the other one immediately. So for example, if you break it, the other one also will break. Whatever happens to this balloon, if you change the gas, it will change the other one gas as well. The Fabrica is basically connection, handshaking. The Barpa effect is the handshaking between Fabricas
Condensate.
in different systems. For example, it can be like, let's say, a plate, and this plate, it can be as wide as possible, but not that much in basically height. Why? Because it can be a representation of the same place for a photon.
Photo.
Yes. This means basically we have a lot of Fabricas getting the handshake and representing one place, not several places for a photon.
So it's in 2 dimension extended.
Yes, it can be also in 3 dimension or like. The thing is, what will happen, this field that we have in quantum theory, always they are talking about same electron, same photon in different places. What places means, because they are referring to non-locality in that way. In this system, we create a Barpa effect and a Barpa system, and this handshaken basically situation will actually represents one place and not several electrons at the same, like different places, but one place.
So electron can be here, there, like.
Actually, it is everywhere in this system because it is the same place, but it got wider. It is like one of the balloons. Just imagine you have like a lot of balloons. One of the balloons got very bigger. It was still one balloon. So basically, the locality of this system, because Fabrica defines the space and time in this theory, the locality of this system can be as wide as the universe, and the effect will be backward and forward what we have in the quantum entanglement, without basically passing the space for entanglement. So therefore, if we have two particles in this field, they are in the same place, still are in the same place, we took them away.
Zero time is needed to come from here to there?
Yes, because they are in the same place. We have one Fabrica which is extended that way, basically on Z1, but on Z1 they are still connected. On X, Y, Z, they have a different situation. It is something like tunneling of general relativity with one difference. In that tunneling, also that is exactly. But in this system, collapsing and converting back to like losing the handshake between all of the Fabricas will be very easy to define, and basically other things like wave will be very easy to interpret. Why? Because this becomes like a field, but representing one place only. A huge wave, but still representing the same place. That's why in double slit experiment, they see two photons. One photon is going through both slits. No, it happens like this. This is the slit. We create one Barpa system. It creates one Barpa system. This is a Barpa system created in this shape. It can be in any shape. It can be in any shape. And basically, this represents same place until we break it. We break this
Observe.
by observation. So we can call this Tbilisi interpretation because it shows why we cannot measure the place of the photon. Why we cannot measure it? That is a big question now, right? Why we cannot measure it? That is why. Because it is still in the same place, but that place shape changed.
But you cannot measure it.
When we measure it, we will break this basically place in this fabrica into like smaller fabricas. The handshake will be destroyed, and it will appear in one of these basically broken hands. Just imagine.